SpaceX is risking it all. They're firing up Starship directly on the launch tower, the same tower worth $500 million that catches rockets. One explosion like Ship 36's blast, the entire tower becomes twisted metal. That's not a 2-month delay, that's a full-year setback. So why is Elon gambling everything on this insane test? Let's dive right in. Here's what nobody saw coming. When Ship 36 exploded at the Massey site, it wasn't just another rocket failure. It was a 500-ton TNT equivalent blast that sent shockwaves through SpaceX's entire timeline. The explosion was so violent it scattered debris across miles of Texas countryside, racking up $300 million in total losses. But here's the twisted part. That catastrophic failure might have just saved SpaceX from an even bigger disaster. After witnessing that destruction, SpaceX faced an impossible choice. Wait for Massey to be rebuilt, a process that would take until September at minimum, essentially wasting an entire quarter when they have 25 flights approved for this year. Or take the nuclear option, conduct the static fire test directly on Pad A, risking their most valuable infrastructure in the process. They chose the nuclear option. Right now, Ship 37 sits fully fueled on the same launch tower that catches billion-dollar rockets. We're talking about placing what is essentially a 5,000-ton bomb directly on top of SpaceX's crown jewel. One COPV failure, that's the high-pressure tank that caused Ship 36 explosion, and Mechazilla becomes twisted scrap metal overnight. But SpaceX isn't just gambling blindly. They've been preparing for this moment in ways that would shock you. On July 6th, something extraordinary happened at SpaceX's McGregor facility. A nearby camera captured what looked like a controlled explosion, white vapor shooting 30 meters skyward, and a dark object launched into the air. This wasn't an accident. This was SpaceX deliberately destroying pressure vessels to understand exactly how they fail. In burst testing, engineers push COPVs beyond their design limits using nitrogen, helium, and cryogenic liquids until they explode. It's controlled destruction to prevent uncontrolled catastrophe. Since the Ship 36 incident, SpaceX has identified the root cause and implemented fixes for Ship 37. But here's where it gets interesting. They're not just fixing the problem. They're using this dangerous test to revolutionize their entire operation. Why would they risk everything for one static fire test? This isn't about Ship 37. This is about data. By conducting the static fire directly on the launch pad, SpaceX is testing every single component of their integrated system. The modified ring stand, the redesigned quick disconnect arms, the entire infrastructure chain. One test gives them real-world data they can use to upgrade every launch pad, making their entire operation more resilient. Think about it. Instead of just testing an engine, they're testing the future of spaceflight operations. Every sensor reading, every pressure measurement, every thermal signature from this test becomes invaluable data for scaling up to their planned 4 launch pads, 2 at Starbase, 2 in Florida. But there's an even bigger pressure driving this insane gamble: NASA's $4 billion Artemis contract. Every day of delay brings them closer to missing the 2026 moon landing deadline. SpaceX isn't just racing against time. They're racing against contracts that could make or break their Mars colonization dreams. While everyone focuses on the explosion risk, SpaceX is quietly deploying their most revolutionary technology yet. Ship 37 will be powered by Raptor 3 engines, machines so advanced that when SpaceX first revealed them, industry experts thought they were fake. Raptor 3 produces 280 tons of thrust, 30% more than the original Raptor, while weighing 100 kilograms less. The engine looks like a skeleton compared to its predecessors because SpaceX eliminated thousands of parts through revolutionary 3D printing techniques. They've integrated cooling channels directly into the metal structure, eliminating the need for external heat shields entirely. But here's the mind-bending part. These engines are so efficient they don't need the fire suppression systems that caused Flight 1's explosion. The very technology powering Ship 37 makes the static fire test safer than previous attempts. Here's where SpaceX's strategy reveals its true genius. They've already factored in losing Pad A entirely. If Ship 37 explodes and destroys Mechazilla, it might actually accelerate SpaceX's plans. Pad A was always going to need major upgrades anyway. A proper flame trench to handle Block 3 Starships with 33 Raptor, 3 engines generating nearly 10,000 tons of thrust. An explosion would force these upgrades immediately, while Pad B takes over operations. And Pad B is closer to completion than most people realize. The massive booster quick disconnect hood that arrived last week is 50% larger than Pad A's version, designed specifically for next-generation vehicles. Its modular, boxy design allows for easier maintenance and greater operational flexibility. The timing is almost too perfect. If Pad A gets destroyed, Pad B could be operational within weeks, potentially handling the debut flight of Block 3 Starships by the end of the year. But there's another layer to this story that reveals just how impossible SpaceX's achievement really is. The Raptor 3 engines on Ship 37 operate at temperatures and pressures that should melt any known material. The main combustion chamber reaches 300 bar, but the pre-burners hit 600 bar, pressures that would crush a submarine. SpaceX's metallurgists have developed exotic alloys with names like SX500, materials so advanced they're essentially classified technology. But even these wonder metals would melt without SpaceX's secret cooling techniques. They pump cryogenic methane and oxygen through microscopic channels carved directly into the engine walls, creating active cooling that keeps the metal from disintegrating. This is why Raptor 3 looks so alien compared to traditional engines. Every external component has been eliminated or integrated into the main structure. The result is an engine that's simultaneously more powerful and more reliable than anything that came before. Here's what makes this static fire test truly historic. Ship 37 is fueled by methane, the same gas you use to cook dinner. But this isn't just about convenience. Methane can be produced on Mars from the atmosphere and underground ice. Every second of this test is preparing for missions that won't land back on Earth. Unlike hydrogen, which leaks through solid steel, or kerosene, which leaves soot buildup preventing reuse, methane burns clean and stores easily. It's the Goldilocks fuel for interplanetary travel. Not the most efficient, but perfectly balanced for SpaceX's ultimate goal of making humanity multiplanetary. When Ship 37 fires its engines on Pad A, it's not just testing Earth-to-orbit capability, it's testing the propulsion system that will one day launch from Mars' surface back to Earth. But here's where the pressure gets truly insane. SpaceX isn't just trying to complete 25 flights this year. They're trying to prove that rapid reusability actually works. Every major aerospace contractor said full-flow staged combustion engines were impossible to build reliably. Every expert claimed you couldn't mass-produce rocket engines like cars. Ship 37 represents the culmination of nearly 14 years of Raptor development. If this static fire succeeds, it proves a SpaceX can iterate engine designs faster than traditional aerospace can complete paperwork. If it fails and destroys Pad A, it proves their critics right about the dangers of moving too fast. What makes this test even more valuable is what SpaceX will learn from the integrated systems. The modified stool-supporting Starship, the redesigned propellant transfer arms, the upgraded quick disconnect systems. All of this hardware is being tested under real flight conditions for the first time. Every vibration, every thermal expansion, every pressure spike gets recorded and analyzed. This data becomes the blueprint for scaling up operations to the point where Starships launch as frequently as commercial airliners. SpaceX isn't just testing one rocket. They're testing the infrastructure for an entire space-based economy. As Ship 37 sits fully fueled on Pad A, SpaceX has reached the point where backing down would be more expensive than moving forward. The Massey site won't be ready until September. Pad B isn't quite operational. Every day of delay costs them millions in lost revenue and pushes their Mars timeline further into the future. But there's something else at stake here, something that goes beyond money or timelines. This test represents SpaceX's fundamental philosophy that the best way to make space travel safe is to make it routine. Every successful static fire, every successful flight, every successful catch brings them closer to the day when launching to Mars is as normal as flying to Paris. The countdown for Ship 37's static fire could begin any moment. SpaceX's beach closure windows suggest it could happen within days. When those Raptor 3 engines ignite, they'll either validate the most audacious engineering gamble in spaceflight history, or create the most expensive fireworks display the space industry has ever seen. But here's the terrifying truth. Even if everything goes perfectly, this is just the beginning. SpaceX has 24 more flights planned for this year, each one pushing the boundaries of what's possible. Ship 37's static fire isn't the end of the story. It's the opening move in a game that could determine whether humans become a multi-planetary species or remain forever trapped on Earth. The question isn't whether SpaceX will succeed with this test. The question is whether the rest of the world is ready for what comes next when they do. So here we are, watching SpaceX gamble everything on a single static fire test that could either validate their revolutionary approach or set them back an entire year. This isn't just about one rocket or one company anymore. This is about whether humanity has the courage to take the risks necessary to become a multi-planetary species. When Ship 37's engines ignite, they're not just testing propulsion systems. They're testing our willingness to push beyond the safe, predictable boundaries that have kept us earthbound for decades. Every successful SpaceX test brings us closer to a future where launching to Mars feels as routine as catching a flight across the country. But here's what keeps me up at night thinking about this. If SpaceX succeeds with this insane gamble, if they prove that rapid iteration and controlled risk-taking can revolutionize spaceflight, what does that mean for every other industry still playing it safe? What does that mean for how we approach solving climate change, curing diseases, or exploring the deepest parts of our oceans? The real question isn't whether SpaceX's static fire test will work. The real question is whether we're witnessing the birth of a completely new way of pushing human civilization forward. And if we are, what other impossible things suddenly become possible? What do you think? Are we watching the future being born, or are we about to witness the most expensive lesson in why some risks are too big to take? NASA engineers are freaking out. SpaceX just pulled off something they said was impossible, transforming their orbital launch mount in less than 30 days into a revolutionary adapter system that has the entire space industry talking. 4 explosive failures in a row nearly killed the Starship program. NASA, the Department of Defense, everyone was losing faith. But what SpaceX just installed at Starbase changes everything. Ship 37 is now 90% ready for static fire. Workers are racing against a 3-week deadline, and this single flight could either save or destroy the entire future of Mars colonization. The most shocking part? SpaceX might be planning something even NASA didn't see coming. Back-to-back static fires that could accelerate their timeline by months. Let's dive right in. Picture this. NASA's top engineers gathered in emergency sessions, watching their Mars timeline crumble. 4 consecutive Starship explosions had turned SpaceX from hero to zero. Boeing executives were secretly celebrating. Blue Origin started talking louder about New Glenn. The Department of Defense was questioning billion-dollar contracts. But NASA's real nightmare? They'd bet everything on Starship for Artemis moon missions. Without it working, America's return to the moon was dead in the water. Then something impossible happened. SpaceX didn't just fix the problem, they revolutionized everything. What SpaceX pulled off in 30 days shouldn't exist in aerospace. Major Launchpad modifications take 6 to 12 months minimum. Boeing needs years for similar changes. NASA takes decades to approve new launch infrastructure. SpaceX ? They rebuilt their entire orbital launch mount in 1 month. On July 18th, workers rolled in the LR 11,000 crane, a 1,100-ton monster that can literally lift skyscrapers. What happened next left industry veterans speechless. They lifted a completely redesigned transport stand weighing over 100 tons and placed it with millimeter precision into the launch mount. But here's the kicker. This wasn't just installation. SpaceX had secretly been welding I-beams and reinforcements for weeks, completely rebuilding the platform's core structure. They'd essentially performed open-heart surgery on a launch pad while keeping it operational. The question everyone's asking, how did they hide this engineering masterpiece from NASA's watchful eyes? Here's where it gets insane. The booster quick disconnect system was never designed for Starship. Think of it like trying to charge a Tesla with a gas pump nozzle. The connections literally don't match. Most aerospace engineers would declare it impossible and recommend building a new pad from scratch. Cost? $500 million minimum. Timeline? 3 years. SpaceX said hold my coffee and did it in 3 weeks. They faced temperatures that would melt steel, liquid methane at negative 259 degrees Fahrenheit, and liquid oxygen at negative 297 degrees Fahrenheit, flowing at thousands of gallons per minute. One microscopic leak means a massive explosion that could level the entire facility. The electrical challenge was even worse. Starship needs completely different power and data connections than Super Heavy. We're talking about systems that control 33 rocket engines producing 16.7 million pounds of thrust. SpaceX engineers literally cut holes in the BQD hood, something considered engineering blasphemy. They installed custom piping that routes over the top, connecting to support frames that didn't exist before. Industry experts called it controlled insanity. But was this apparent madness actually genius? While the world watched Ship 37's preparation, SpaceX was playing 4D chess. Ship 38 wasn't just being built, it was racing toward completion in parallel. Heat shield installed June 17th. Forward flaps mounted July 20th. Full systems integration happening simultaneously. Why keep 2 Starships combat ready at once? Traditional aerospace, test 1, fail, investigate, rebuild, repeat. Each cycle takes 6 to 18 months. SpaceX just shattered that paradigm completely. Their strategy? Back-to-back static fire tests with 0 downtime between vehicles. If Ship 37 reveals issues, Ship 38 launches immediately with fixes. No delays, no waiting, just relentless iteration. NASA's internal emails reveal they're fundamentally reassessing development methodologies based on SpaceX's approach. Translation: they're scrambling to copy what they previously called